2a.
2a?
Yeah, question 2a.
Yeah, what's the question?
Using the substitution, e to the x power
E to the x
equals
is equals to
3 cos theta,
3 cos theta.
or otherwise determine the integral of e to the x power multiplied by the square root of 9 minus e to the 2x power dx.
E to the x power?
Yeah, dx.
dx. Okay, how much marks is that for?
8 marks. Yeah.
8 marks?
Yeah.
Alright, let's go. So, what we can do first? First thing on this one.
Yeah.
First thing you want to do is basically go and substitute e to the x equals to this here. This is the most first to do. But then we figure out that you should, what would you want to know? You differentiate what? E to the x and the cos, the 3 cos theta, right? Here, Jessica. So the first thing you want to do is dUd. We can put it down back first down here, work with. So now we can actually start off. So we get e to the x multiplied by 9 minus e to the 2x dx, right? And they give us this here. So e to the x equals to 3 cos theta. So the first thing you want to do is basically differentiate both sides, or dx equal to, right? You can't get dx both sides, that make no sense because this will disappear. So you want to do is differentiate both sides, right and left. Alright, so when you differentiate e to the x, what do you get? E to the x, right?
dx.
Good, dx. So you get e to the x dx
D theta, sorry.
over d theta. And
Well,
this gives a step, right? So you can when you differentiate e to the x, you get e to the x dx. And when you differentiate this side, you get what? So when you differentiate trig with the function, is the function put in front of bring up put the functions here. So when you differentiate cos theta, you get what? Minus sign. Because when you differentiate cos is what? Negative sign. What is the chain? What is the chain? Sine. Cos. Minus sine. Minus cos. Good. And when you reverse the integration, you remember it? Good. So we get negative 3. When you differentiate cos theta, you get what? Sine. So you get this minus sine. So you put the negative in front. Sine theta, d theta. Correct? Alright, next step. What do you want to do? So basically, you're looking for, you want to substitute something for dx. This is the goal. Right? You want to plug in something for dx here. So, the only way you can plug this off for dx, guys, is by doing what? Finding for dx here. Right? So who's next to dx you want to get rid of? E to dx. So he's currently multiplied, so you're currently going to what? Divide. So you get minus 3 sine theta d theta all upon e to dx. Alright, so now that we get this here now, we can take this here, plug everything with dx equals to into here. Good? So we're going to speed now. Speed time. E to the x multiplied by 9 minus e to the 2x multiplied by, we know we have to back dx because we know dx is equals to minus 3 sine theta d theta all upon e to the x. Good? Lock it for me. E to the x and e to the x do what? Cancel out. But then we have a impasse there. What do we have here? E to the 2x, Anissa. What are we doing with that?
we substitute d3 cos theta.
Good. So you can substitute basically 3 cos theta into it. Good. But something very, just because we know this is not e to the x here. This is e to the 2x. Or the same, what's e to the 2x, guys? Yeah, no, e to the 2x is also the same thing as e to the x all square. Get it? So we multiply back this 2 with x and you what? 2x given. Right? So what we can do, we put it back. But we know we just utilizing this as a substitution. Focus on me. Good, Jessica? So we get what? We get root of 9 minus, instead of putting e to the 2x, you put what? 3 cos theta squared. Steve, Jessica. 1 second. Squared. Put back everything here, Jessica. What we have just now? Minus 3 sine theta d theta. What do we do now here, Anissa? What's happening here? What do you see here? Jessica. What do you see here, Jessica?
Root?
Yeah, root. But look at it, Jessica. A square here. Look at it. That's it. Different two squares here. Both we had this if you want like on the paper. So we get what the integral of. This is current to 3. What was it? Squared minus, we put it back, but it's okay. Square multiplied by the negative, guys, Let me walk this start. We carry this negative out further. We do that?
Yeah.
We can actually carry the whole negative 3 outside, you know. Yeah, we do that?
Yeah,
We
minus
can take this whole negative 3 present here,
plus
all the way outside. So we get negative 3 out here. And what the block is what? Sine theta d theta. We will Lisa?
Yeah.
What we could do next, Lisa? Talk to me. The next step you want to take.
This is I will multiply by everything in cos theta.
You
And
multiply
then
what?
Find the identity. And then factor out the 3 to the square
Okay.
and find the identity for 1 minus cos square theta, which is, yeah.
yeah. See,
Can we do that?
Okay, come here. What is that?
Basically, I would like multiply it to get 9 cos square theta, and then it be like I will factorial 9, so be 9
So you can multiply into which 2?
1 minus
This 2 it?
yeah.
In there. Okay, so you want to reverse this step?
Yeah.
Good. So we reverse this step. This is okay. We did part, we work me together. Right? This is okay. So you go back here, you said. Go back integral sign, the root of 9 minus. She actually is square Jessica. She put only the purpose, this difference square. Good? So this square is holding Jessica, we get 9 cos square theta. Good? Kaya yung square both 3 and the cos theta. Put back in negative 3 out here. Okay, put it just now. And I got sine theta out here. D theta. So we could do it. Yeah, ask me. So let me go. We go.
Yeah.
So you can put factor in 9.
Yeah, factorial 9.
So you can negative 3 we put 9. 9. So you can be the root of 9 bracket 1 minus cos square theta. Good luck, guys. For the persons who are not watching, what we did just now, we basically reverse the step. So we get
9 times sine square theta.
1 minus cos
9 times sine square theta.
square theta. Because 9 was common in both here, right? Both of these. By the way, you can actually multi-bracket them. Multi-bracket will be sitting better. 9 is common in both, say pull the 9, so what back is 1 minus cos square theta. And then you put back sine theta present here. D theta. Good. Lock in. Next step. What you can do? Use the identity, right? This is the same thing as what? Was 1
sine
minus.
square theta.
Was good. So we know this identity here.
Sine
Sine
square
square
plus cos
theta plus cos square theta is equals to 1. So we know that sine square theta will be what? 1 minus cos square theta, which is here. Good. So you can convert theta sine. So you get negative 3 integral of the root of 9 sine square theta sine theta d theta. Alright. Next step. You don't know what happened there. Right? What is the turn into, Jessica? Look at it good. Huh?
3 square.
Well, because the 3 square, but the square and square, the root, everything in disappears. So left box is what? What do you think left box, Sanjeev?
3 sine theta.
3 square theta. Alright, let me go back. Wait a minute. Just here. Saying what? The root of. Actually, yes.
Tama?
Look at me. You make it look more nice. This means what? The root of 9, the root of. Get it? Jessica, look at this here. 9x squared, the root of 9x squared, this is Jessica. You should know the same. The root of 9, root of x squared. You can do that. You can come and multiply, back and multiply, everything inside the root and about this here. Good? So, look at this now. So we get the root of 9, the root of sine square
Yeah.
theta, sine theta, put back the sine theta over there, d theta. We get more settled, but this is just the other side. Over here, negative 3, the root of, well, the integral of, sorry. What was it? Root of 9, Jessica, quickly. 3. When it's square and square, you know, disappear. So the back is what? Sine theta. And we have it multiplied by sine theta, d theta. Good. Alright. Next 3 and the negative 3 become what? Negative 9. And this will become what? Sine square theta, d theta. From here now, Jessica, what we do next? What would you do next, Anissa?
Basically, there's nothing.
Do we know
the
stuff?
identity.
Do we know stuff for sine square theta? We have stuff, right? Don't want to pay it. It's not here. Yeah, we never call it that. Yeah.
My brain stopped working. I always spell morally.
Huh?
My brain stopped working. I always spell morally.
Morally?
Yeah.
M-O-R-A-L-L-Y.
Right. Thank you.
Good. Tell me again before we will use cosine square theta. They put Nikani here.
1 minus
So sine square theta is equals to 1.
minus cos 2 theta over
Cos
You
square.
read? Huh? 1 minus
Cos square.
cos 2 theta
cos 2 theta
Oh.
over 2. That's it? Just one then. Sorry. Good? We could have twisted and see. Or we could have get stuff. But if you don't farm it to Sanjay. In pure 1. When we do your recap of pure 1, you can see. This is going to stick in your head. Alright. We know we can't go integrate this trig with a square here. This is why we have to go into that. Right? This is the reason. Because you can't integrate any part here. So you get negative 9. Integral of 1 minus cos 2 theta all 1 2 d theta. Back out. What we gonna do? Come on, this is easy. What we gonna do? First thing. You can separate, right? So look at this, Sanjay.
9.
You get negative 9. The integral of what do you do? A half minus what?
Cos 2 theta.
Minus cos of theta. Half 1.
2.
2. And you don't know the dt to be covered both. Simple and bracket. Integrated piece by piece. What do you go on this one? Negative 9. What do we get?
a half theta.
A half theta. You know I put this bracket here, right? Because it's negative 9. I can cover both of them. Good? So when you integrate a half, when you integrate any constant, you can put what? The whatever you're referring to. So in this case, dt is going to be kt here. Minus what? Integrate, you know. May you just go integrate cos of theta. When you integrate cos, you get what? Sine. Okay. But when you integrate this 2 theta, you don't differentiate and put in front. You just gotta do this. Differentiate again, but put it here.
The bottom.
At the bottom. Good? So, we get clean over. You get sine 2 theta. Remember your function no change. Good? Sine 2 theta all upon what? Quick.
2 by sine 2 theta.
Well, no, remember you can't carry everything downstairs. You only differentiate the function with the function 2 theta. So, you differentiate 2 theta, you get what? 2, and I carry it where?
At the bottom.
At the bottom. So, you give 2 times this 2 percent, you give you what? 4. How many divided 2 with 4, Jessica?
It's only 4?
Yeah.
Kinda.
Right? Never. Steve, give me 1 second. Good. Me and you, Jessica. Let's go. You do something wrong, Jessica, or not? You do nothing wrong. Good? So far. But we got put this, so what are we missing on this one?
B2.
What are you missing on that? After then integrate, you miss it.
Plus 6.
Plus here. You know we like it to be easy just right?
Oh.
Why we not stressing ourselves with all these things? We could have just pull the whole 2 here
Outside.
outside and work it, but that's okay. We already get it, so we can just work with it. Next step. What do we do next? Jessica. What do you want to do? What will be our next step? Come here. Yeah.
We need to convert it. Oh.
You can't fit
Convert it back into
Which math you went for?
8.
8?
You can't fit just or you got to distribute it.
You gotta go lock in now.
So you gotta convert it back to x.
You gotta convert it back to x. You start off with what?
Or dx.
E to the x, right? So everything gotta go back to e to the x. What do we do now?
You use we really get 3 to the x bar equal 3 cos theta final theta.
Alright, so she said here, she kind of look find the theta here. You get what I'm saying? Jessica? So she know that. Remember when I give you this question to Jessica, here e to the x. We got theta, cos theta, and sin theta here. So we gotta convert it back to what? E to the x. Good? So, we saying that, Jessica, we gotta go on to what? We're gonna take this here and find for theta. So we can plug everything with theta equals to back in theta. So we get, what we carry over first? Me on this, there you go. Carry over 3. So you get what? E to the x
Over 3.
upon 3 is equal to cos theta. We don't need to harmony, so we got carry over now.
The cos and become
So it can become what?
inverse.
Cos inverse of e to the x upon 3 is equals to theta. Works. This is actually works. Next step. What do we do next?
Substitute.
Substitute?
Yeah.
Okay. So we see theta, we're going to plug in the value. Okay, so we get what? Negative 9 into half multiplied by, what is multiplied by that? So there you go.
Cos inverse e to the x.
Cos inverse e to the x upon 3.
Yeah.
Next. Minus
Sine 2.
sine
Okay, though.
2 of theta.
No, cos inverse
Cos inverse of,
e to the x over 3.
do something wrong, right?
We did?
Can we solve it through that?
This is what I'm saying. Can we do that? We can't, right? We can't get a sine and a cos present here. So we have to go a different step. I want to ask you. Oh yeah, I think it's a step. Where?
I think there's an sine to rotate now.
Good. Let's go and rectify it now. So from here, we can take this up. This is good so far, right? Where we said that the cos theta is equals to e to the x over 3. Pause, no? Alright, good. So we don't know for the theta, this is good to theta, but we cannot input theta here for this part here, right? We can't do that. Because you get sine and you get cos inverse percent. So we have to rectify the part. So, instead you got my identity for sine 2 theta, so go. Tell me.
Yeah. Sine 2 theta is equal to 2 sine cos theta.
2 sine theta cos theta. Good? Good. So we lock in. What can we do now?
And we can find for cos theta from the same thing that they give us e to the x equal 3.
Good.
Where we just carry over the 3.
So we have this already. This part. Yeah? Do we? We don't cos theta. Who cos theta just give me everything. Good? So you got e. Do we have 2 sine theta though? We can't find 2 sine theta. Watch it, Jessica. Watch it. Look at this here. So, how many carne? We can't catch any carne?
I'll bring it back.
You catch it? Say, catch the
Yeah,
pieces.
yeah,
no?
kitchen.
You catch it? Alright, look at this here. Here we got find. This we got find. Look at this, Jessica. Look how this example. Steve. We know cos theta is equal to. What cos theta is equal to? Can we? E to the x of 1, 3. This is a bayat sisig. Yara masuk ito? Masuk ito kasi. So to. So what is it? So cos theta is equal to adjacent over hypotenuse, right? Yeah, lock in it. Let's drop a triangle.
Triangle.
Okay. So this is theta. And what are you giving me? Hypotenuse is what? E to the x. What is adjacent?
Hypotenuse is 3.
Hypotenuse 3. Sorry. What is adjacent? E to the x. Is the opposite is going to be adjacent E to the x, right? Make sense? So we gotta find this piece here. How do we find this piece? Pythagoras theorem. What's Pythagoras theorem? A square is equal to a square plus b square. What's h? 3 square is equal to a square. What's a square? We say a square, we want to find that. So you put back a square here, right? So this is a, we want to find e. Plus b square. What's b square? E to the x square. Alright, so we take over this is saying well, you get 3 squares 1, 9. Just go last thing 9?
Yeah.
E to the x square is what? E to the 2x. Good, remember that?
Yeah.
Because e to the x square means what? 2 times x?
Minus.
Oh, shoot,
Yeah,
first.
minus.
Because it's positive here to be in subtract. E to 2x is equals to a square. Therefore, a is equals to 9 minus e to 2x just because the root of it. Look at it though. Ooh, you get to work. You get to work something looking like that. So this is a good sign. So we find a. But we didn't want to find no a though. We only going to find a because we got to find sine theta. What sine theta equals to according to C said sine well. Opposite of so we know a is equals to 1 now. We can put it in red. What a equals to?
Root 9 minus 8 into
9 minus e to the 2x. Good? So since 9 a is equal to 9 minus e to the 2x, we can basically plug in everything we have currently from to solve it. So it can be opposite of adjacent. Opposite is what? The root of 9 minus e to the 2x. all upon what? All upon what, guys? Hypotenuse is what? 3. Let's confirm everything is good. I think we made a mistake, or we didn't make a mistake?
No, I didn't.
You make a mistake? Okay, this is supposed to be good then. Lock it. Maybe you, Jessica. No, Jessica, do we have sine theta?
Yeah.
Do we have cos theta as well?
Yeah.
Cos theta is here. We have sine theta. So we get 2 multiplied by sine theta. What's sine theta? Root of 9 minus e to the 2x all upon 3 multiplied by cos theta. What's cos theta? E to the x all upon 3. Let's go simplify. So you get 2. I'll put everything in front how I want it, right? How I want it. So I'm going to put 2 multiplied by e to the x root of 9 minus e to the 2x all upon 9. Good? So I know what sine 2 theta now. What sine 2 theta? All of that nonsense given here. That's sine 2 theta. So I have sine 2 theta. I have what theta. Can I multiply it now? I can. So we get negative 9 into a half multiplied by, you know what? Guys, back into me. I want to pull 2. I know 2 is common here. Half, actually, sorry. It's common. So I can pull it up. So I can be negative 9 upon 2. The 80 this 2 can disappear, Jessica. But we know what you like, Baki. 2. Get it?
Yeah.
You guys see what I'm saying? See what I'm saying? It's like finding LCM. Get what I'm saying? So we know that 2 is common. So you can pull only half. Because a half multiplied by theta you what? Half theta. The half multiplied by 2 divided by what? 4. Good? So it can be negative 9 upon 2. You have theta present minus sine 2 theta. Sine 2 theta upon what? Or we can say what? Look at this thing. We can say half sine 2 theta. Yeah, good? Lock in. Plus here, of course. Wait,
You're done removing.
this is a bracket. This is supposed to be a bracket. My what? Negative 9 upon 2. What's theta? Okay, what's it now?
Cos inverse.
Cos inverse
E to the x over 3.
e to the x upon 2.
3.
3 minus what? A half. What sine 2 theta?
2 e to the x.
2
E to the x.
e to the x
Root 9 minus e to the 2x
root 9 minus e to the 2x
over 9.
all upon 9. Well, see? Look at this now, Jessica. Ready the fun part? This is the fun part. This cancel. So we'll have back. Or what we could do, we can leave it. Now,
Oh,
we can simplify it. You can't chop a heel. Easy to see the same. This one is to cancel out.
B minus bracket.
We can carry it in. We carry it, right? You ready? We can multiply this by everything moving inside. You ready? So you get what? Negative 9 upon 2 cos inverse of e to the x upon 3. Negative times negative give what? Positive. This 9 and that 9 will do what? Cancel out. So the bucket to Jessica. E to the x, the root of 9 minus e to the 2x all upon. If this and this cancel out, we'll have bucket what? 2 at the bottom. Take that. That's about it.
Take it off.
Not yet. 1 second. Let me double check and see if everything is okay. E to the bang. Bang. Yeah, see. That's it. Take it up.